This is the second of the two parts exploring circle theorems, and hopefully you've watched part one, and hopefully you'll find these two questions also useful in your preparation for your exam. Sometimes with circle theorem questions, you'll also have to bring in knowledge of other angle rules, and this is a good example. So this question here, we have parallel lines. They are mentioned in the question, and they are also shown on the diagram. So when I see that, I'm going to think, well, I'm probably going to be using either co-interior, corresponding, or alternate angle rules within my solution. Also here, it says in the question, the diameter of a circle. It hasn't got the diameter marked, hasn't got the center marked, but it's telling me the diameter of a circle. So in that case, I'm going to be looking for a triangle where I have a 90-degree angle. And also, I have a tangent, but no center or radius marked on the diagram, or even no radius referred to. So I've got the tangent without the radius, then we're looking at alternate segment theorem. So those are the three things I'm going to look for. So studying the diagram, I have ABC. That's my triangle with a diameter. So I know already the angle ACB is going to be 90 degrees. So I'm going to mark that on. I'll draw a little arrow, and I'll just say that the angle in a semicircle is 90 degrees. So that's the first bit. Now, studying with this triangle here, if I have two angles, I know the third one. So this angle here is going to be 180 minus the 65 plus the 90, which is going to be equal to 25 degrees. And that's because angles in a triangle add to 180 degrees. So this angle here is 25. Looking at my parallel line, I have the alternate segment theorem here. So if this angle is 65, I know this angle here is going to be 65. So here, and because it goes over the line CD, I'm actually going to write the angle here to remind myself that it's not one of the smaller parts, it's not this part or this part, but it's the whole thing. So that is 65. And while I'm here, then this angle here, alternate segment theorem, is going to be this angle here. So this angle here is going to be 25. I suppose I should really write the rules for that. So I'm going to just pick one of them. I'm going to go a little arrow to the 65 and just write alternate segment theorem. Don't need to write the whole theorem out, which is a relief. Okay, so that's what I've written down so far. Haven't really done much thinking about the question. And then studying the diagram again, I go, oh, hang on a minute, A, B, C, D. Oh, that's a cyclic quadrilateral. It's a quadrilateral where each point is touching on the circumference of the circle. So therefore, if this is 65, I know what this one is, because this one is going to be 180, take away 65, which is going to be 115. So draw a little arrow to this one, and just go opposite angles in a cyclic, making sure I don't write cyclical, cyclic quadrilateral, add to 180 degrees. So what I did there was did 180 minus 65 equals 115. Okay, so that might come in useful as well. What else do I have? Well, if I know that one is 115, then I know this angle here. Angle's on a straight line. So that's just going to be 65 degrees. So I have angles on a straight line. Angles on a straight line. Add to 180 degrees. And now let's have a look at the question again. I'm trying to find angle ATC, which is this angle here. Now ATC appears in two triangles. It appears in this one, and it appears in this one. So if I work with the big triangle here, then I know this angle, so I just need to find this angle here. And if I work with a smaller one, then I have to find this one here. And looking at it, I think the big triangle is going to be the best one to work with. So that's the one I'm going to focus on. So I have 65, and I just want to find this angle here, which I'm going to again mark in blue. And I'm going to use this angle 65 here, so I'm going to mark that one in blue as well. Okay, so what have I used so far? I've used my alternate segment theorem, which I wanted to. I've used the diameter. which I thought would come up, and I haven't used the parallel lines, so it's probably the parallel line rules. Now, if you look at it, I have these two parallel lines here, and these two angles, this big angle here and this one here, will add up to make 180, which means that this angle is 65, which makes this angle 40, because co-interior angles add up to 180 degrees. So this is getting a little bit messy. Let's do a little arrow here. And I can go 180 minus 115 plus 25 equals 40 degrees. Co-interior angles add to 180 degrees. And now I have my triangle. My triangle here going down here and across here. So ATC, I know two of the angles, so I know the final one. So I know that this angle here is going to be 180 minus 65 plus 40, which equals 75 degrees. And this is just angles in a triangle. And I've already used this rule before. Add to 180 degrees. So with a question like this, take it step by step. Look for the clues in the question itself, giving you an idea of what rules you're going to use, making sure you probably use them as you go through. Show your reasoning, work out the angles, keep checking through, and then you should get to the right answer. Sometimes we get questions which involve algebra with circle theorems, and it's not straightforward what you're going to have to try and do. I think this is one of them. If we look at the shape we have the circle, we have this shape inside here, and these lines coming out here. So these are formed two triangles. That's quite easy to spot. But notice that this is a cyclic quadrilateral. So we know the only rule with cyclic quadrilaterals is that the opposite angles make 180 degrees. So if I have this as x, I know what this one is. So whether I'm going to use it or not, I'm going to write that in 180 minus x, and the reason would be opposite angles in a cyclic quadrilateral add to 180. I also know that I have a straight line here. So if this is x, this is also 180 minus x. Angles on a straight line make 180, so that's 180 minus x. Now, if I know this angle here, because it's going to be 180, take away these two, because angles in the triangle make 180. So it's 180 minus 39 plus 180 minus x. If I work that through, the 180s cancel. I get minus 39 minus x, which is going to be x minus 39. So I know what this angle is in here. This angle and this angle are the same. I'm not going to write it on here, though, because it's a maths question and clearly something else is going to be going on. But what I know now is that, hang on, if I can come up with an angle here, then I can form an equation, equating these two, and then maybe I can solve for x. So let's look at my second triangle on the right-hand side here. I know that this angle has already been stated as this. So this one here, let's mark that in red here. This angle is just going to be x, isn't it? Because these two angles must make 180, and if this is 180 minus x, and this must be x. And if this is x and this is 56, I know what the blue one is, because this angle then is going to be 180 minus the other two angles, which is going to be x plus 56. So that's going to be equal to 180 take away 56, which is 124 minus x. Now you hopefully can see where we're going with this, because I have one expression for this angle, one expression for this angle. They are both equal, and they are both in terms of x. So in that case, I can just equate them. So let's do that one at the top. I know that x minus 39 will equal 124 minus x. That's one equation with one unknown, x, so I can solve. I'm going to add x to both sides to give me 2x minus 39 equals 124. Add 39 to both sides, so 2x equals 100, and I think that's going to be 63. So x is going to be half of 163. So x is going to be equal to 81.5 degrees. Not a particularly pleasant question. It's more about forming equations and solving them than circle theorems, but these are the sort of things you could be asked in an exam. The starting point for this, remember, was just writing on there what I knew and then trying to realize that I can get things that are equal. So when you've got algebra and you're trying to find a value, you want to form an equation and try and solve it. In this case, it was using the opposite angles are equal theorem or rule, which is here.